Hello. In the last class, we have discussed the type of grammar. Now, in this class, we will discuss uh, left linear and the right linear grammar. So, left linear grammar, left linear, and right linear, right linear. Yeah, left linear, right linear grammar. Now, what is left linear grammar? Or first, we have to discuss what is a linear grammar. So, first we will write linear grammar, linear grammar. So, linear grammar is basically a grammar in which at most one non-terminal or the variable can occur on the right hand side of any production without restriction on the position of the variable. So, we can define a linear grammar, a linear grammar is a grammar in which at most one non-terminal at most one non terminal or variable can occur on the right hand right hand side of any production without restriction on the position of the or of this variable. Then we call it as a linear grammar. Regular grammar is always linear, but not all linear grammars are regular. So we can define the regular grammar is any, either it is a left linear or a right linear. So a regular grammar is any left linear or right linear. Right linear. So that means a regular grammar, either it is a left linear or a right linear. Now we define the left linear as well as the right linear grammar. Okay. So first we will define what is a left linear grammar, or then we will discuss the right linear grammar. So our definition of right linear. So right linear grammar. Okay. Now a grammar, we can define formally like that. A grammar, suppose G is equal to Vn sigma Pn S is said to be right linear if all the all productions are of the form. What kind of form? A to x B or A to X. Means this A and B are basically the non-terminal. Yeah, so this A and B belongs to the variable or non-terminal, and X belongs to terminal star. Yeah, where so if the production are of that form, then we call it as a right linear. The variables appears right. Now suppose suppose finite automata accepting strings that start with B. Clear? So if we want to design a finite automata that it will accept strings that starts with B. So the diagram will be like that. Okay. From here, by taking B, starting with B, so B, one B will be received, then there may be A or B, and this is the accepting state. Okay. Now, what will be the uh, grammar production rules for this? So production rules will be A to, we can write here that B and B2, we can write epsilon, we can write BB, or we can write AB. So now using these production rules, all the strings that have or that starts with a B will be accepted. So the regular language corresponding to this right linear grammar, the regular language corresponding to right linear grammar is, what will be the language? A, first B, then BA, BB, BAA, BAB, and so on. So by using this production rules, we can generate this language. Okay. Now, if we change or if we reverse the above production, okay. So now first we give the definition of the left linear grammar, then we'll reverse this. Okay. So now definition is a left linear grammar. Okay, definition of left linear grammar. So a grammar is said to be left linear if all productions are of the form A to Bx or A to X, and all other meaning here A, B belongs to non-terminal and X belongs to terminal, as we have defined like this. A, B belongs to Vn and X belongs to sigma star. Okay, so variables appears left. Now, if we reverse if the reverse of the above productions means here the productions that we have obtained for this finite automata, that is A, that is if we reverse these productions, what will happen? So now if we reverse this production, the production will be A to BB or B to epsilon or BA or BB. So now look the pattern of this production form. So it basically represents the left linear grammar. Now the language that will be generated by this left linear grammar is basically look like this B, because if we put here the epsilon then only B will be generated. Now if we replace this B by BA, then A B will be generated. If we replace this B by BB, then BB will be generated. Okay. If we replace this B with BA and again this B will be replaced by BA, then B will be generated. Clear? And if we replace this BA and again this B will be replaced by BB, like this, A derives BB and then this B will be replaced by BA and this B will be replaced by BBAB and this B will be replaced by epsilon, then it will be BAB. This will be replaced by epsilon. So BAB also there. So this is basically the pattern. Now if we reverse this string, so what will happen? B AB, right? B and AB, and BB. If we reverse BB, it will remain same here also BB. Now if we reverse this BAA, if we reverse it will be AAB. So it will be AAB and so on. So basically it generates the language which is a reverse of the language L. So we can write it is basically language reversal L of R, that is that we have generated for the right linear grammar, and then and the language that is basically generated by the left linear grammar is basically reversal of this language. Right? Now already we know the set, so or any set represented by the regular expression is known as the regular set, and set are basically accepted by, or regular set are basically accepted by the finite automata. Okay. Now we'll give an example like this. Suppose the grammar is given like that. G1 is a grammar which is given like that. S is a non-terminal and these AB are terminals, production P1 and S, and where P1 is given as S to ABS or A, right? So obviously it is a right linear grammar. So we can say it is a right linear grammar. Another grammar we say G2, which is defined by using this S, S1, S2, terminals are AB, production is suppose P2 and start symbol S, where production P2 is defined as S2, S1 AB, S1 to S1 AB or S2B and S2 is A. This is also a left linear grammar. So this grammar G2 is basically a left linear grammar, and this grammar is basically G1 is basically right linear grammar. Now from G1 and G2, every production here is a right linear in the form of right linear. Here in that case, grammar G2, every production are of the form of left linear. So both G1 and G2 are regular grammar. Regular grammar. As we have defined here that a regular grammar is any either left linear or right linear, but not both. So that's why both G1 G2 are regular grammar. Now we'll take another example. To suppose there is a grammar G defined in this way: S A B, then A B productions and S with P S to A to AB or epsilon, and B to AB. Clear? Now here in these productions, it may be right or left linear. Clear? In this production, it is a right linear. Clear? In this production, it is a left linear. Clear? So the grammar G, you can say it upon it is G3. So the grammar G3 is not regular. Clear? But the grammar is a linear grammar. But the grammar G3 is a linear grammar. Why linear grammar? Because in the definition we have explained that on the most one non-terminal variable can appear on the right hand side of any production without restriction on the position of the variable. That's why though G3 is not regular, because regular grammar means either it is a left linear or right linear, but here the productions are mixed. This may be right or left linear. It is a right linear, but it is a left linear. So that's why it is a linear grammar, but it is not a regular grammar. Okay. So thank you.